Hey guys, welcome back to another video. So today I'll be doing Euclidean geometry for grade 11. So this is circle geometry both for grade 11 and grade 12. This information is very important for you guys to know so that we can ace those exams and get the best mark, because it has a lot of marks. It's paper 2, so it has a lot of marks. It's probably 40% of the question paper. So if you know this work, then you really know, and you can be able to get better marks on your exam. What I will also advise you to do is look at the geometry 2D. I think it's 2D geometry in grade 10. That will really help you a lot as well, because sometimes they like to throw in those parallelograms, those squares, rectangulars, rhombus, and kites. So in order for you to know the properties, I have a video just before this one where I explain that theory. I think it's called geometry theory, grade 8 to grade 12. So you will know whatever that you have to know, so that when you have those complicated circle questions that you have to solve, you are not panicking and you know a whole lot of theory. So guys, without wasting any time, let's get into this video. All right, so we can learn the basics of circle geometry. Now let's come here and learn this first. What we need to know, you need to know what is a radius, what is a chord, what is a diameter, what is a tangent, and what is a secant. So we are firstly going to start with a radius. A radius is a line from the center to any point on the circumference. So we have a circle here. This is the center of the circle, and this line drawn from center to the circumference, it's the radius. So that's how you know any short line drawn exactly from center. It can be to here, it can be here, going up from center to the circumference. That is a radius. Now, what is a circumference? The outside of a circle is the circumference, right? So when you ask what is a circumference, this is the outside of the circle. That is what a circumference is. So a line drawn from center to the circumference, it is a radius. Now let's see a chord. A chord is a line with end points on the circumference. So that is a chord. This line that is just drawn from one end of the circumference to the other, it is a chord. Now we have to know what is a diameter. A diameter is a course passing through the center of the circle, right? This is a chord, but this one passes through the center. It is no longer a chord, it is a diameter. So this diameter, if you shave off this part, it will become a radius, right? So a diameter is always 2 times the radius. Okay, so here we have a tangent, a line touching the circle at only one point, which is this line here. It touches the circle once. That is a tangent. And then we have a segment, something that we call a segment. A segment is this under, this is a chord. Anything under that chord here, if the chord is drawn from here to here, we say this is a segment, or here we say this is a segment. This is where the diameter is here. The chord drawn from center is the diameter, and then we say the segment is this side, right? And then a sector is a line passing through 2 points of the circle. So here, this is a diameter, this is a radius. So this can be our sector. Now let's go to theorem number 1. So still on Euclidean geometry grade 11s and grade 12s. I hope you are enjoying the video, and if you are, please don't forget to give it a thumbs up to show that you are liking this video, and it encourages me to create more videos. All right, here we are. This is a radius, but it does not get to the circumference, and this is a chord. This one is a complete chord. Now theorem number 1, Euclid found out that a line drawn from the center of a circle perpendicular to a chord bisects the chord. What that means is, if this is a circle, you draw a line from circle, you draw a chord, and then this is the a center, you draw a line from center bisecting the chord. Perpendicular bisects that we are gonna form 90 degrees, right? So a line drawn from the center perpendicular to the chord bisects the circle, so bisects the chord. So this is drawn exactly at center, so it cuts this into half. That will be indicated by this. When you are given this question, they will give these two lines to show that from A, let's say this is C, this is O. Let's say from A, this says AC is the same as CB. That's what we mean there when we say, so when you give a reason, when you're writing an exam, you say line from center bisects the chord, right? When you prove that AC is equals to CB, right? So let's prove that. Now you are given this circle, right? Now let's try to prove really that let's say the question says that prove that AC is equals to CB. The first thing that you're going to do, all right, when we have to prove that AC equals to CB, the first thing you have to do is draw the line. Draw a line from O to A and draw another line from O to B. So I am going to say that is the line, and this side as well. There is my line. So the first thing that I am going to do is say OA equals to OB. This is OA equals to OB, and the reason is radi, which is radius. Kitty, those things are called radius. They are drawn from center to the circumference. So any line drawn, even if you can draw it from here going that side, would still be the same length as this one, because this is the center. Any line from the center to the circumference, no matter where you are drawing it, it's the same. So that is radius. The reason why OA and OB are the same is because it's a radius. A radius is the same length wherever, as long as it's drawn from the center, because that's what it is. A radius is drawn from the center. So a radius is the same anywhere. And then now let's go to the second one. We will say C1 equals to C2. Now we have C here, right? So this is C1 and this is C2. Sometimes, guys, they will give you an extra sheet, right? they will give you all the circles in a question, and there will be extra circles which are given to you, which are not part of the question, but they're just coming as additional. Just like when you are given a graph, or you have to write a graph, you are given this circles like that. This is where you have to write and submit them. So you have to write this one, and submit those things, because you're going to get marks for that. So don't forget, on your June exam, we're not going to make the same mistakes we made on first term, because other schools have written already with some parts of this Euclidean geometry. So C1 equals to C2 equals to 90 degrees, right? And what do we say? It is given. They will give you this with that 90 degrees there. So that one is given. Whatever you are given in the exam, you just write it as given. Even in the question, they will tell you, when they give you this question, they will write things already. They will tell you proof. So this is equals to what, is equals to what. Then your reason for those things that have already been explained to you by the examiner are the reason for you to say that it's given. So you don't have to, like this one we say radi, which is radius. You don't have to say that, just have to say it's given. You have given it to me, so I am always also acknowledging it and using it to prove my case. Because here what you're doing is proving your case, stating your case. The reason why I'm saying this this statement is true, that AC equals to CB, is because of including the information that you were already given. So that's what you have to remember, right? And then now what we can do now is that OC for this triangle equals to OC for this triangle, and the reason is a common line. They both have a common line. So OC equals to OC, and that is common. They both have a common line. OC here for this triangle is the OC for this triangle. So these two triangles have a common line, right? Yes, that's what you do, and that is your reason, right? And therefore, triangle OAC equals to triangle OCB, and therefore AC equals to CB. So we used triangles to prove that AC equals CB. We also used the radius and all that to indicate and prove our case. So I hope you guys understood this. I tried to make it as easy as possible for you guys to understand the question. So sometimes you may be given this question and told that AB equals to 12 centimeters, right? So that automatically tells you that you're going to divide this by 2, which is 6. Then AC equals to 6, and CB is also equals to 6. So this is 6, and this side is also 6. And then you can also be given that maybe this side is 3 centimeters, and you are asked to find the radius. You can find the radius using this triangle or this triangle, right? So if we use this one, you are going to use Pythagoras. R squared equals to x squared plus y squared. This is the Pythagoras. Which is the R? The R is the longest side. Now the x, this side will be 6, and this is the y. that will be 3 squared. So you will have 6 squared plus 3 squared. You square root that, and that will be equals to this length here, right? That is how you do it when you are given that part. Sometimes you'll be given this radius, you will be given this, and then this whole thing is extended like this, and then this is C, and then you find that this is maybe D, and you have to find the length of CD. You just have to find the length of CD. You are given this part maybe, and you are given, yeah, given this, and you have to find this. You firstly have to find the radius here, and then the radius here, you're just gonna minus this part, and you have find this, because this is the radius is the same as this one. You see, guys, this is quite easy. You just have to look for things, and the most important part is that you have to practice. If you can, just do everything in your textbook or download previous question papers. I have a WhatsApp channel, Zane Private Tutors. You can search for that on WhatsApp. I think it's under communities. I will be posting worksheets very, very soon, so you can check that out in the meantime, or check my Facebook page, which is Zane Private Tutoring. Private Tutors, Zane Private Tutors. I have posted a link there to my WhatsApp channel, which I will be posting very, very soon, probably next week. Activities, worksheets that you can do with memos. You can practice and improve on your maths. All right, now this is theorem number 2. Theorem number 2 states that the angle subtended by an arc at the center of a circle is double the size of an angle subtended by the same arc at the circumference on the same side of the chord as the center. So what this happens is that angle at the center is 2 times angle at the center is 2 times angle at the circumference. So how do you know that this angle O, we're going to call it angle O, is 2 times angle C? You first have to draw. You first have to make dots like this. Then this triangle goes out and make that one. So that's how you know if you are able to get 2 triangles when you do here. Then you know that angle at the center is 2 times angle at the circumference. All right. Now, if you are asked to prove that angle at the center is 2 times angle at the circumference, what do you do? So the first thing you have to do when you want to prove that this angle at the center is 2 times angle at the circumference is you do this. Share this triangle into 2 like that, and then you can have O1 and O2. You see, like that. Let me emphasize this again. You'll be given an extra sheet. On that extra sheet, you are required to draw. So draw as I have shown you here. Draw, submit it, and you are going to get marks for that. For this, your drawings, it's marks. Submit it to your teacher with those extra sheets that they were provided. When you're provided with extra sheet, it means you must draw. All right. So what we can say when we have to prove that this angle is 2 times this one, the first thing we can say is that O1 is equals to C1. This is C1. This is C2. These things that I'm drawing, you also draw. O1 is equals to C1 plus your A. Let's do that here. O1 equals to C1 plus A, and that is extended angle of a triangle AOC. That is an extended angle of a triangle. This AOC is an extended angle, right? So this is equals this plus this, right? So this is equals these two angles added together. Now, because this is 2 times this one at the center, so the next thing now what you can do is that now we can prove using a radius. OA is equals to OC, that is radius, right? OA equals to OC. What is that? It's radius. You can say radius equal or just radius. Your teacher will know that this point is drawn from the center to the circumference, center to the circumference. So they are the same. You see how easy is this, guys? You just have to know. Even if you get a very complicated question, you can figure this out if you really apply your mind and the theories that you have learned. Now, another thing we can see is that C1 is equals to A. C1 equals to A. And those are opposite angles of a triangle. I told you this. If you have watched my previous video, then you know what this triangle is. So those are opposite angles of a triangle. Opposite angles. Angle A, opposite equal sides. Angles opposite equal sides, right? Or you can say opposite sides of a triangle, right? Yes. Then you have proved that this and this are equal. Then this plus this equals this. This and this are the same. So therefore O1 equals to 2 times C1. So this part here equals to 2 times this. You can do the same for this triangle, but you have simply just proved that angle at the center is equals to angle at the circumference. This is an isosceles triangle, so these sides are equal. Sometimes you can get this. This is still angle at the center. You just write, make dots here. Your drawing is that these are 2 triangles. Then this is also still can prove that this angle is 2 times this angle. Or with this one, this angle here is 2 times this angle. All right, now we are in theorem 3. Theorem 3 tells us that the angle, wait, let me do this. Theorem 3 tells us that the angle subtended at the center by a diameter is a right angle. We say that the angle in a semicircle is equals to 90 degrees. So angles in a semicircle. So this here equals to 90 degrees. If you have a line passing through the center like this, a diameter, and an angle opposite, any angle opposite a diameter is 90. any angle opposite a diameter is 90 degrees. You have a line passing like this to the center. Any angle opposite, even if it's this side, is angle in a semicircle. Okay, so an angle in a semicircle opposite the diameter is equals to 90 degrees. All right, guys, don't forget that, please. Now, what we can do is to maybe, let me see if I can find something. Then if maybe you are asked to do that, if to prove that this is 90, you can simply say if A, C, B, which is, when you see this kind of a cap on top, you must know this is the angle we are looking for, equals to 90 degrees. Then AB is a diameter. So whenever you see this, there's not much that we can do here, but whenever you see this, you can just say angles in a semicircle. So prove that this is a 90. Just say AB is a diameter. All right. For theorem 4, this is what we have, right? This now from theorem 4 and 5, I think we're now going to, this can be used to prove a cyclic quadrilateral. Anything that has 4 points, this has 4 points, is cyclic quadrilateral. So this is a bow tie, right? Yes, with this bow tie, we are told that an angle subtended by a chord of the circle on the same side of the chord are equal. We say that angles in the same segment. So here we are talking about angles in the same segment, meaning this and this are equal, this and this are equal. They are called angles in the same segment. Yes, here as well, what we do is to draw as well. I'm going to draw like that. You see, this triangle ABD is also for me a triangle of A, C, and B. So by this drawing, we are indicating these two drawings that we have here, that we have two triangles. So really, this can help us prove angles in the same segment, or we can do the drawing here.